what is an index? An index or an index. So I'll also send you these notes after we're done with this class, okay? So an index is a repeated multiplication of a number. Repeated multiplication of a number. Alright. So, for example, let me illustrate this. If you see like 2 to the power 3. Alright. Remember, this 3 here, this power, is also called the index. The index, or the exponent, or the power. Or the power, whichever you feel comfortable with. Okay? Then this 2 here represents what we call the base. Could you kindly mute your mic? This represents the base. Okay, so we remember 2 to the power 3 is the same as saying 2 times 2 times 2, and that gives you 8. Okay, so basically an index is a repeated multiplication of a number. So today we're going to look at the laws of indices, okay, because once you understand these laws, you'll be home and dry. Okay, they're very important. Okay, so we're going to say the first law which is the multiplication law. Multiplication law. Okay, so let me write it down here. A to the power m multiplied by a to the power n. So what the multiplication law says, if the bases are the same, okay, with the majority of these laws you have to make sure the bases are the same. So if the bases are the same, as you can see the base a here and the base a here are the same, then it means you just need to add the indices, okay, which is the same as a to the power m plus n. So let me give an example to illustrate this multiplicative law. Let's say, for example, if you have 3 to the power 2 multiplied by 3 to the power 3. Okay, we can see we have the same base, which is 3 here. Same bases. So if the bases are the same, then you can add the indices. So it's the same as 3 to the power 2 plus 3 here, which equals 3 to the power 5. Alright, and we can simplify this. 3 to the power 5 is just basically 3 times 3 times 3 times 3 times 3. Okay, so 3 to the power 5 basically is, let's say, just get my calculator for this. Three to the power 5 is 243. 243. Any questions so far? Remember, I am very patient, so I'm not going to rush. Where you have questions, feel free to ask. Okay, let me just illustrate this law one more time. Let's say if you are dealing now with variables, which are basically just letters in mathematical terms. If you have x to the power 3 multiplied by x to the power 4. As we can see again, same bases. Okay, you only apply this law if the bases are the same. So same bases, so it's this like x to the power 3 plus 4, which gives us x to the power 7. Okay, that is the multiplication law. Okay, now we go to the division law. Okay, so with the division law, this is how it is. A to the power m over a to the power n. So when you have same bases dividing each other, you just subtract the indices. So this is the same as a to the power m minus n. Okay, we are dividing the same bases, so you subtract the indices or the powers. Okay, so for example, if you have 3 to the power 5 over 3 to the power 2, as we can see, same bases here, so this is the same as saying 3 to the power 5 minus 2, which gives us 3 to the power 3. Okay, which we can simplify, which becomes 27. Okay, if we use variables, letters, all right, right, if we say x to the power 7 over x to the power 3, same bases, x and x here, so it's x to the power 7 minus 3, which will give us x to the power 4. Okay, so these loads, they only happen if the bases are similar. Okay, if the bases are not similar, you cannot apply the law. That's what you need to remember. If the bases are not similar, you cannot apply the law. Okay, any questions on the division rule?
No.
Okay. Next, we're now going to look at the power of a power rule. Power of a power rule. Okay, so here basically, if you have a to the power m raised to the power n, it's just the same as saying a multiplied by n. Just multiply the powers, and that will give you a to the power m n. right? So let's say, for example, if you have 2 to the power 3 to the power 2 here, so it means you're going to multiply these indices together. Okay, so it will be 2 open brackets the power 3 times 2, which will give us 2 to the power 6. Okay, and 2 to the power 6, basically, let's see, 2 to the power 6 we get 64. Okay, another example, if you have y to the power 3 raised to the power 5, you just multiply the powers. Y to the power 5 times 3 gives you y to the power 15. Okay, that's the power of the power rule. So these laws, you'll be given questions where you need to apply all of them simultaneously. So you have to first understand them each step by step, so that once you're given a question, you know what law to apply and where to apply it. Okay. Next. Oh, any questions on this law?
No questions, sir.
Okay. Next, power of a product. Okay, so power of a product. A times B to the power n is the same as A to the power n multiplied by B to the power n. Okay, so for example, if you have 2 times 3 to the power 2, it's the same as saying, so this power, what's happening here is this power, you're distributing it to the numbers inside the bracket here and here. That's the same thing we did here. Distributed this power here and here. So this is the same as 2 to the power 2 multiplied by 3 to the power 2. Alright. 2 to the power 2, that is 4. 3 to the power 2, that is 9. 9 times 4, 36. Now, if you are dealing with numbers, you can just easily multiply 2 times 3, that is 6. 6 squared to give you 36. It's just what when you're dealing with letters, variables, okay, you will see this law getting applied more often. But if it's numbers like this, if you want, just multiply what's in the brackets. 2 times 3, that is 6. 6 squared, that gives you 36. Okay. But in a situation where you have variables, which are also called letters, because in maths, when we say a variable, we're usually referring to these letters. Okay. So if you see x like this, xy to the power 3, that's when you apply it now. Okay, you distribute this power 3 here and here, so that you get x to the power 3, y to the power 3. Any questions on this one?
That's clear. We are following.
Wonderful, 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 wonderful. All right. So these laws, as I say, with maths, it's mostly about practice. So I'll be giving you practice questions so that you remember these laws, because you are going to see them in other topics. You see it being applied, like especially in financial mathematics. Okay, you're going to see indices with compound growth. Okay, or if you're trying to find the growth factor of something, maybe if it's in economics, you're trying to find the growth factor of a GDP, you see the application of indices. Okay, so you have to remember all these rules so that you are not caught wanting. Power of a quotient. This one is just the same as saying, like if you have a divided by b to the power n, the same as saying a to the power n divided by b to the power n. Okay, let me illustrate that with an example. Okay, if you've got x over y to the power z, okay, same thing, you distribute this power here, you give it to the x, give it to z, or let me even just put the number here, x over y to the power 2. Okay, you just distribute the power here and the power there, so that you get x squared over y squared. Okay, yes. Okay, and I'll assume that this one is also clear. It's just the same like that power of a product rule, and this time it's just with division. Okay, now we're going to negative exponents. These ones you are going to see them a lot. Negative exponents, you are going to see a lot of these. Negative exponents. Alright. So if you have 1 over, oh, not like that, sorry, a to the power negative n. Okay, this is the same as saying 1 over a to the power n. Okay, so with a negative exponent, you're getting the reciprocal basically. Alright, so for example, if you see 3 to the power negative 2, it's the same as saying 1 over 3 to the power 2, and this becomes 1 over 9. Okay, if you see x to the power negative 3, the same as saying 1 over x to the power 3. Okay, then there's also another variant of this rule. Okay, this is the variant, 1 over a to the power negative n is the same as a to the power n. Okay, this is the variant. 1 over a to the power negative n is the same as a to the power n. So if you see, for example, 1 over 3 to the power negative 2 is the same as saying, it's the same as 3 to the power 2, which gives you 9. Now let me just illustrate this a bit more so that you get the concept. Okay, if we have to solve it in the long way, we use the long cut. Okay, this is how the long cut can be. Right, we say 1 over 3 to the power negative 2. We can apply this first law, a to the power negative n, 1 over a to the power n. Then our fraction will look like this: 1 over 1 over 3 squared. Okay, basically what we're just saying is 1 divided by 3 squared. This triple fraction here, which I've written there, is the same as saying 1 divided by 1 over 3 squared. Okay, so one trick you can use if you're ever in this situation where you have like this 1 over 3 squared, one trick you can use is you just bring this 3 squared to the topmost numerator. Okay, and let me show you how it can easily come to this topmost numerator. Okay, what you can do is this: if you try to divide it like a fraction, remember when you're dividing fractions, the sign changes from division to multiplication. And when the sign changes from division to multiplication, the denominator comes on top and the numerator comes down. So the same as 1 times 3 squared over 1, which will give you 3 squared. Okay, colleagues? But all you just need to remember is this: if you see 1 over a negative exponent, just do this. Okay, no need to do all these tabulations here, just apply this law here. Okay, that's the law for negative exponents. Any questions? Okay, then the final law, fractional exponents. This is one law which gives a lot of students headaches, this one. Okay, a to the power m over n is the same as the root of n, and you put a inside here and you close the brackets to the power m. Okay, the root of n to the power n. So let me show you what this means. For example, if you have 8 to the power 1 over 3, so always remember here, the denominator is what determines the root. Okay, as you can see here, this denominator was this root here. So even here, it means we're getting the cube root of 8. Okay, cube root of 8. So the denominator is what determines the root. Then the numerator, okay, is the power after you've done your tabulation of the root. Okay, and the numerator, as you can see here, the numerator of m is here. Okay, so here to the power 1. Okay, this 1 has come outside here. So the cube root of 8 is excuse me, is 2. Okay, then you say 2 to the power 1 equals 2. Okay, here's another example. Let's say you have 8 to the power 2 over 3. Okay, 8 to the power 2 over 3. As I said, the numerator, the denominator is what becomes the root. So again, you're getting the cube root of 8. Then after you get the cube root of 8, the numerator is going to be representing the power. So cube root of 8 squared. Right? So the cube root of 8 is 2. So you have 2 to the power 2. 2 to the power 2, that equals 4. And that is your answer. Any questions?
No, sir, I'm good. I'm following. But I have to go save food for my husband. He just knocked off from work. I think I'll come follow through the record. The donors will be here by 21:15, 22, sorry.